So first we have our accelerometer and gyroscope, which is the gray board right here connected to the ESP32. We are using the Arduino IDE to program, and so I will click this upload button to load our code onto the ESP32. You can see on the bottom right here that our microcontroller is connected to the USB, so via serial communication. And so the IDE will connect to the board and basically write, and then reset automatically once it's done. And we can observe our results on the serial plotter. The blue line represents motion, and the red line represents whether the patient is on their back or not. And so the supine value, which is in red, is a Boolean, where 1 means they're on their back and 0 means they are not on their back. And so you can observe that when I move the system, it detects motion. And so you can see the spikes. Basically, it's using the X, Y, and Z values read from the accelerometer and calculating the motion out of that. And then for the supine value, basically it's an algorithm from a research paper that I found, which compares the X, Y, and Z values and determines whether or not somebody is on their back. And so that is our accelerometer and gyroscope. Okay, so next we have our pulse ox and heart rate monitor, which is the green sensor right here. The red light is on, so it's getting power. Again, we're using Arduino IDE. The code has already been loaded, and this time we're going to use the serial monitor to observe our readings. And so I will place my finger on the sensor, and we can observe my heart rate as well as my oxygen saturation. There are valid bits, so if it gets an invalid response, it just means that my finger is not placed correctly, and so I can readjust and it will give me the right values. Lastly, we have our microphone. I've already loaded the code from the Arduino IDE to the ESP32, and I've got the serial plotter running. It's been sitting for some time, so that's just some low-level noise, like the clock ticking and stuff in my room. And so if I bang the table, you'll see that spike. And then for testing purposes, I'll play a snoring sound effect, and we will observe the spike going up and down. So yeah, each time you heard the snore, you saw that spike go up, so we can monitor snoring with this microphone. And so yeah, that was our third sensor. Okay, so putting all the components together for our final system, we have code for our accelerometer gyroscope, the pulse ox and heart rate monitor, and the microphone, which I've already loaded onto the board. And so basically each value is red, which I already tested that. So you can see the oxygen saturation, heart rate, motion, and whether or not it is supine. And basically all of these values are sent to the ThinkSpeak IoT platform, which we can see in this window. And so basically this platform gets data from the Arduino code, and you can log all of the information on a single web page. It's very easy to view and keep a track of the timestamps, so we don't need to use a real-time clock on the ESP32. And so in summary, if there is a spike in motion, a drop in oxygen saturation, a spike in heart rate, and some snoring detected, then there is a likelihood that the patient has obstructive sleep apnea. Moreover, if the patient is on their back for a period of time when all of these events are satisfied, then there is a likelihood that they have supine OSA, which is very predominant. So in summary, we have successfully managed to create a system that helps diagnose obstructive sleep apnea. In the future, for expansion, we would choose smaller versions of the same sensors so that we could integrate it in a wrist-based device. Also, we would add a battery feature so that it doesn't have to be a desktop and can be worn throughout the night. But in the end, we have found a cost-effective method to help diagnose OSA, meeting our sponsors' requirements.